we are looking at theorem 1 here, and you should be able to state the theorem correctly, and well, you should be able to identify theorem 1 in riders, but maybe that is not today's business. But of course, and other things, theorem 1, the important thing about theorem 1 that you need to know really is that whenever we are using theorem 1, you should remember to apply the Pythagoras theorem, especially when you are calculating the sides. You need to appreciate the Pythagoras theorem. And the other thing that is important in theorem 1 is being able to prove the theorem itself. Now the question is, can you prove theorem 1?
Yes, sir.
Okay. Well, I'm going to do it here for the sake of anyone else who is going to watch this particular presentation. I'm going to talk about how we prove theorem 1 with a diagram like this one. However, is not the diagram that we find when we are proving theorem 1. It's a diagram that you find when you're proving the converse of theorem 1. So when it comes to theorem 1, you will have a diagram like this one. Here I'm going to put my circle right there, like that. So then we have the center O, then you have the chord, let's call it AB. And then we'll have the line drawn from the center. Then let's call this M. What does theorem 1 state? What does it say?
It says that a line if a line bisects no a line drawn from the center of the circle perpendicular to the chord bisects chords.
The line drawn from the center of a circle perpendicular to a chord bisects the chord. So we're saying the line drawn from the center perpendicular, right? So that is theorem 1. Please understand that this one, so if let's call this C here. So we are saying if AB is actually perpendicular to OC, then we can conclude and say what? AM is equal, because they say it bisects, right, to MB. So this is the part that is required to prove. We can conclude this. We can say, yes, please, this is true. But this is the part that is actually required. If you are proving, that is the part that is required of you to prove. So now my question is, how then do we do that? So here is the solution. Let us take our same the circle that we actually had. with the center O here, and then we had oh my god, this is too small. I need to redo this one. Well, let us say we have our circle with its center over here and the chord AB. Then we have the line drawn from the center through M to the point C. So here is the solution. So number one, for you to obtain full marks, you need to also indicate that you need to tell us the construction. Because in every theorem that we need to prove, you need to construct. This is the only part in Euclidean geometry where you are allowed to construct in order for you to come up with your solutions. In answering basic riders, you do not construct, okay? You just use the information that you are given. So construction, let us say join, since this is our center O, join OA and OB. So I'm joining OA and OB, like that. So what is the aim? I'm going to put this aside because it's not really part of your construction, but it's the way to think. So what you need to end up with is to say that your goal is to have to conclude and say AM is equal to MB. So here we use, since we already have the right angle here at M, so we need to prove right angle, hypotenuse, side. You know, some of the students, I don't know, they just say right hand side. I don't know, it's kind of crazy, but I mean it's kind of nice. It reminds you what you need to do. So you need to prove that these two triangles that you have now constructed, because now we have two triangles, right? We need to prove congruence in terms of what? They are congruent because they, in terms of the right angle, the hypotenuse, and the side. So let us start off by right angle, right? So we're saying OM. So let's say in triangle what? OMA. Since I said OMA, I'm also going to say OMB. So in triangle OMA, I want to start off with the right angle, right? The R there. So I'm going to say OMB. For OMA, sorry, for OMA, I'm going to say what? OMA is equal to what? OMB. I'm talking about the angle OMB. They are equal to 90 degrees. Actually, that is given. Now I need to talk about the hypotenuse. So for OMA, I have OA. So OA is equal to OB. That is the hypotenuse part. These are radii. Then after that, I need to talk about side, which is the common side. Then I say what? OM is equal to OM. As you can see, we are talking about the same side, so this is common. So after having managed to prove the three things, we can therefore conclude and say triangle OMA is what? Is congruent to triangle OMB. Why? Right angle, hypotenuse, side. That is the method that we use to prove congruence here. So if you look at that, it is true to say MA, this side, and that side are equal, as you can see. So MA is equal to MB. So we can therefore say, therefore, AM or MA, right? In this case, they wanted us to say AM. Oh, maybe they didn't. AM is equal to MB. The reason being what? These are congruent triangles. So this is how you then prove the theorem, this one. So in the next presentation, I'm also going to teach you how you prove the converse of theorem 1. Alright, that's cool. Then the other thing that I mentioned that you need to know is that the moment you are, so here I said if this one is perpendicular, then AM is equal to MB. If you're given, like this particular diagram here, you are given that AP is equal to PB, therefore you can conclude and say OP is perpendicular to AB. So that is the thing that I was saying here. If AP is equal to, then you can conclude then and say what? OP is perpendicular to AB. It's very important for you. Then if you are moving in the other direction, so like I said here, there are two directions that you can take that you might need to identify. If OP is perpendicular to AB, then AP is actually equal to PB. Or you can be given that AP is equal to PB, then OP is perpendicular. Then there is another subtle way of showing this. They will tell you that the line is passing through the center of the chord. So if the line passes through the center, then and then it casts the chord, we can conclude and say, wow, it is perpendicular, and it bisects the chord, and we can actually also say, well, it passes through the center, or in the opposite direction, right? That is the thing. Then the other thing that I wanted us to really also appreciate here in theorem 1 is the use of the Pythagoras. For example, we're saying OA in this particular thing, OA is 5 units and AB is 6. So AB is 6, it means that AP will be 3 and PB is 3, and OA is 5. So for you to find OP, you can actually appreciate the Pythagoras theorem and then calculate what is missing. That is the thing that I was just talking about there. The order is theorem 1 first, identify the theorem first, and then you apply the Pythagoras. You don't apply the Pythagoras and then do the theorem. That is basically incorrect, right? So look at this question that I extracted. O is the center of the circle, then AP is equal to PB, and they said OQ is perpendicular to CD, and CD is equal to 8 centimeters of the circle. Then the radius of the circle is 5 centimeters. So the radius is the line that is drawn from the center to the circumference. OQ is not the radius, OP is not the radius. The radii that we have here are OA and OC. So determine with reasons the length of OP and the length of PQ. And then later on explain why AB is parallel to CD. So the first thing, what is the information that we have? We know that AB is 6 centimeters, so therefore AP is 3. Why? Because it's the line from the center perpendicular to the chord. Then after identifying the theorem, you then apply the what? Your Pythagoras, just like that. So that is the thing that I was doing here. So we're saying, well, we know that what did they want? We wanted OP, and we know that AO is 5 and AP is 3 from the theorem, right? So we have 3 and we have 5 there. That is the hypotenuse, so we are subtracting in order for us to find x. So that is the thing that we were doing here, and that was it. So it's the same thing as that. Okay, here are the mistakes. Please understand it is wrong to use the whole chord in the Pythagoras. You need to only use half of it. Please, you do not have to mix the theorem and the converse, and do not forget to state the theorem before you start applying your Pythagoras. And my God, it is a very waste of time for you to be writing your statements without reasons, because a statement without a reason is just incomplete. So it's as good as nothing. It's just wrong, and you don't want that. So if you see the center, find the perpendicular item. You need to know that that is theorem 1. But if they give you items where they tell you that maybe this distance from there, maybe halfway through the chord is equal, then you need to apply the converse of the theorem. And I also gave a couple of activities here which you can try at your own time. You're just gonna take a screenshot, or you can pause the video later on, try to answer the questions. Then after that you can look through the memo, which I also put right below it here. Then you can try to mark for yourself. So basically these are the things that I was just talking about in theorem 1.